Welcome to Niti Connects, Mathematics for Upper Primary. We will look at the before and after concept.
The agenda of this presentation includes an introduction to Spark, S-P-A-R-K, a strategy recommended for solving word problems, what heuristics are and the heuristic skill before and after, difference unchanged. Lastly, we will also cover some hands-on activities. At the end of this session, parents will be able to 1. Identify what their child is learning in school for word problems. Number 2. Become more familiar with some types of word problems. And number 3. Support their child in using some of the heuristics to solve word problems. At Primary 5, students are expected to solve up to 2-step word problems involving the 4 operations in whole numbers and fractions, plus ratio involving 2 or 3 quantities. At Primary 6, students are expected to solve up to 3-step word problems involving 4 operations in topics such as whole numbers, fractions, percentage, and speed. Spark is a strategy for students to manage word problems. First, study the problem. What do you know about the problem? What do you need to find? Second, plan your strategy. Have you solved similar questions before? And what strategy did you use back then? Then act on it. Perform the required operations. Finally, reflect and keep checking. Is your answer reasonable? Does it make sense? So, what are heuristics then? Heuristics are a set of problem-solving approaches that help us discover the most practical ways to solve problems. By the time a student reaches Primary 6, he or she would have completed learning all the listed heuristic skills in the table here. This presentation will be focusing on covering the heuristic skill using the before and after concept with difference unchanged. The definition of this is that the difference in quantity remains unchanged before change and after change. For this type of questions, it can exist in 2 types of situations. The first type of situation involves age difference. The second one involves external transfer of equal amounts. For today, we'll be looking at situations involving external transfer. Word problems for these situations can be found in topics such as ratio, fractions, decimals, and percentages.
Let's take a look at the first example involving ratio. Let us read the question. At first, the ratio of Alan's savings to Beth's savings was 3 to 4. After each of them gave $10 to their sister, the ratio of Alan's savings to Beth's savings became 5 to 7. What was Alan's savings at first? We can use model drawing to help us solve this question, but it is not necessary to do so. Since Alan and Beth both gave away the same amount of money to their sister, the difference between Alan's and Beth's savings remains the same. For the before situation, the ratio of Alan's savings to Beth's savings was 3 to 4. This means that Alan had 3 units, Beth had 4 units, and the difference between their savings is 4 units minus 3 units, which is 1 unit. Let's first write down the ratio for the before situation. The ratio of Alan's savings to Beth's savings to the difference between their savings is 3 to 4 to 1. For the after situation, the ratio of Alan's savings to Beth's savings became 5 to 7. This means that after giving $10 each to their sister, Alan has 5 units, Beth has 7 units, and the difference between their savings is 7 units minus 5 units, which is 2 units. So, for the after situation, the ratio of Alan's savings to Beth's savings to the difference between their savings is 5 to 7 to 2. We know that the difference between Alan's and Beth's savings should remain the same. So, we need to multiply the ratio for the before situation by 2 throughout to get 6 to 8 to 2. What we are trying to do is to arrive at the same number of units for difference in both before and after situations. We now see that the difference between their savings is 2 units for both the before and after situations, allowing us to compare both ratios. The change in their savings is 6 minus 5 or 8 minus 7 units, that is 1 unit, which is equivalent to $10. So 1 unit represents $10, 6 units represents $10 multiplied by 6, which is equals to $60. Alan had 6 units at first, which is equivalent to $60.
The second example we will look into is before and after concept involving fractions. Let's read the question. Mrs. Ng baked 18 muffins. 3/5 of the muffins were lemon muffins. The rest were chocolate muffins. She gave away an equal number of lemon muffins and chocolate muffins. She then had 5 times as many lemon muffins as chocolate muffins. How many muffins did she give away? How can we identify that this is a before and after concept where the difference is not changed? The hint is gave away an equal number. The first step is to find the number of lemon muffins and the number of chocolate muffins. There were 80 muffins and 3/5 of the muffins were lemon muffins. So 3/5 of 80 will give us 48. There were 48 lemon muffins. If there were 48 lemon muffins, we take 80 minus 48 to give us 32, and there were 32 chocolate muffins. Now we know that before there were 48 lemon muffins and 32 chocolate muffins. The difference between the number of muffins is 16. Mrs. Ng gave away an equal number of lemon muffins and chocolate muffins. She then had 5 times as many lemon muffins as chocolate muffins. How do we draw a model to show 5 times as many lemon muffins as chocolate muffins? I usually start with the one with the fewer units. In this case, it is chocolate muffins. So, 1 unit represents chocolate muffins and 5 units represents the lemon muffins. The difference between the number of muffins is still 16. So 4 units represents 16 muffins. 1 unit represents 4 muffins. In the end, there were a total of 6 units. So 6 units represents 24 muffins. Before, there were 18 muffins. After, there were 24 muffins. So, the number of muffins given away is 80 minus 24 to give us 56. 56 muffins were given away.
The third example we have is on decimals. Let's read the question. At first, Justin had $484.40, while Kenneth had $288.20. After they each spent the same amount of money, Kenneth had 25% as much money as Justin had left. How much did each boy spend? We can look at the problem from a unitary perspective and solve it using model drawing. In order to minimize confusion, we look at the after situation when Kenneth had 25% as much money as Justin had left. This translates to Kenneth having 1 unit and Justin having 4 units, or Justin had 4 times as much money as Kenneth, depicted in the model drawing. Note that 25% is 1/4 of 100%. After spending the same amount of money, the difference between the amount of money they had in the end or after is the same as the difference they had at first or before. This means that the difference of 3 units depicted in the model represents the difference between $484.40 and $288.20, that is $196.20. If 3 units represent $196.20, 1 unit would represent $196.20 divided by 3, which is $65.40. $65.40 is the amount of money Kenneth had left. We would have to subtract this amount from what he had at first to get what he had spent. That would be $222.80. We can check if we had obtained the correct answer by substituting the answer into Justin's case. If Justin had also spent $222.80, he would have $261.60 left. As shown above, 1 unit represents $65.40. Justin had 4 units left. He would have 4 times of $65.40 left, which is $261.60 left, which is correct. We can also solve the problem using percentage. If what Kenneth had left is 25% of what Justin had left, the difference in the proportion of money they had left would be 75%. The 75% represents the difference in the amount of money they had. And 25% of that amount, which is a third of 75%, would be $65.40. And what Kenneth had spent would be $288.20 minus $65.40, which is $222.80. Or, in Justin's case, 100% represents $261.60. And what he would have spent, the same as Kenneth, would also be $222.80.
The fourth example is on percentage. Let's read the problem first. A florist had 125 flowers. 80% of the flowers were roses and the rest were sunflowers. She sold an equal number of roses and sunflowers. In the end, she had 6 times as many roses as sunflowers. How many flowers did the florist sell? Let's list all given before change, the change and after change information. No conversion is needed since the information is already in units and numbers. We know the difference between the number of roses and sunflowers remains unchanged. So we make the difference after change, that is 5 units, equal to that before change, and that is 75. We can find the number of units after by adding the number of units, that is 6 plus 1 equals to 7. That would give the number of flowers left to be 15 times 7, and that is 105. The number of flowers sold can be found by subtracting the number of flowers left from the original number, that is 125. This gives a total of 20 flowers sold. Now it's time for some hands-on.
Let's try together a problem involving ratio. Read the question carefully and try this on your own. Please pause the video while you try out this question. Press resume whenever you are ready. Ali and Sean shared some stamps in the ratio 3:1 at first. After each of them received 15 stamps from their teacher, the ratio of the number of stamps Ali has to the number of stamps Sean has became 7:4. How many stamps did Sean have at first? Ali and Sean received the same number of stamps from their teacher, so the difference between the number of stamps each boy has remains the same. For the before situation, the difference between the number of stamps Ali has and the number of stamps Sean has is 3 units minus 1 unit, which is equals to 2 units. So, the ratio of the number of stamps Ali has to the number of stamps Sean has to the difference is 3:1:2. For the after situation, the difference between the number of stamps Ali has and the number of stamps Sean has is 7 units minus 4 units, which is equals to 3 units. So, the ratio of the number of stamps Ali has to the number of stamps Sean has to the difference is 7:4:3. Since the difference should remain the same, we find the lowest common multiple of 2 units and 3 units, which is 6 units. This means that we need to multiply the ratio for the before situation throughout by 3 to give us 9:3:6, and to multiply the ratio for the after situation throughout by 2 to give us 14:8:6. We now see that the difference between the number of stamps each boy has is 6 units for both the before and after situations, allowing us to compare both ratios. The change in the number of stamps each boy has is 14 minus 9 or 8 minus 3 units, that is 5 units, which is equivalent to 15 stamps. So 5 units represents 15 stamps, 1 unit then represents 15 divided by 5, which is equals to 3 stamps, and 3 units then represents 3 multiplied by 3, which is equals to 9 stamps. Sean had 3 units at first, which is equivalent to 9 stamps.
Now, let's try together a sum on fractions. Mrs. Lim baked 60 pies. 3/5 of these pies were chicken pies and the rest were tuna pies. She gave away an equal number of chicken pies and tuna pies. In the end, she had 4 times as many chicken pies as tuna pies. How many pies did she give away? The first step is to find the number of chicken pies and the number of tuna pies. There were 60 pies, and 3/5 of the pies were chicken pies. So 3/5 of 60 is 3/5 times 60 to give us 36. There were 36 chicken pies. If there were 36 chicken pies, there were 60 minus 36 to give us 24. There were 24 tuna pies. And the difference between the chicken pies and tuna pies would be 36 minus 24 to give us 12. We take 1 unit to represent tuna pies and 4 units to represent the chicken pies. The difference is 3 units. 3 units represents 12 pies and 1 unit will represent 4 pies. In the end, there is a total of 5 units. So 5 units will represent 20 pies. Before, there were 60 pies. In the end, there were 20 pies. So 60 minus 20 will give us 40. 40 pies were given away.
Let's try together a problem involving decimals. Read the question carefully and try this on your own. Please pause the video while you try out this question. Press resume whenever you are ready. Lindy had a roll of ribbon. She cut out 15 pieces of 0.3 meters from her roll of ribbon and had 21.5 meters of ribbon left. Manasi also had a roll of ribbon. She cut out pieces of 0.25 meters from her roll of ribbon. In the end, the ratio of the length of ribbon Lindy had left and the length of ribbon Manasi had left remained 5:4. How many pieces of 0.25 meters did Manasi cut out from her roll of ribbon? What was the length of Manasi's roll of ribbon at first? The difference in the length of ribbon Lindy had left and the length of ribbon Manasi had left remained as before or unchanged. This means that the total length of ribbon Manasi had cut out was the same as the total length of ribbon Lindy had cut out. Lindy had cut out 15 pieces of 0.3 meters of ribbon, which totaled up to 4.5 meters of ribbon. Manasi would have cut out 4.5 meters of ribbon too. Since each piece cut out by Manasi was 0.25 meters, she would have cut out 4.5 meters divided by 0.25 meters, which is 18 pieces of ribbon. In order to find out the length of Manasi's roll of ribbon at first, we have to find out the length of Lindy's roll of ribbon at first. After cutting 4.5 meters of ribbon, Lindy had 21.5 meters of ribbon left. This means Lindy had 26 meters of ribbon at first. Since the length of Lindy's roll of ribbon to the length of Manasi's roll of ribbon remained 5:4, the length of Lindy's roll of ribbon would represent 5 units, and the length of Manasi's roll of ribbon would represent 4 units. This worked out to 20.8 meters. Did you get that?
Let's read and try the next problem together. It involves percentage. Read the question carefully and then work out the problem. Parents, please pause the video while you complete the before and after table. Press resume whenever you are ready. The problem reads, Tom has 120 marbles. 60% of the marbles were blue and the rest were white. He gave away an equal number of blue and white marbles. In the end, he had 7 times as many blue marbles as white marbles. How many marbles did Tom give away in total? Read the question carefully. First study the problem. What is it telling us? We are told Tom gave away an equal number of blue and white marbles. So we know the difference between the number of blue marbles and white marbles remains unchanged. So We make the difference after change, that is 6 units, equal that before change, and that is 24, which is obtained by subtracting the number of white marbles from the blue marbles. We can find the number of units after adding the number of units, that is 7 plus 1, which is equal to 8 units. This would give us the number of marbles left to be 4 times 8, which is 32. The number of marbles given away can be found by subtracting the number of marbles left, 32, from the original number, that is 120. This gives a total of 88 marbles given away, which is the answer. We have come to the end of the mathematics sharing for upper primary in this month's Unity Connects 2021. We hope you have learned a very important heuristic skill to enable you to work with your child when solving word problems. Thank you.